Okay, I'm actually gonna have two videos today. This is gonna be the first one. I'm gonna show you where the law of sines comes from. And then the second one, I'm gonna do problems. So I'm gonna explain it first, and then I'm gonna do the problems. You are gonna turn some problems in today, but they're gonna be on the second video. So make sure you look at the second video. So all of the triangles that we've dealt with have been like this with a 90-degree angle. And it's been real simple for us to do stuff. But now we're gonna deal with some triangles that do not have a 90-degree angle in them. And we're gonna have to try to figure out how to figure out the sides and the angles based off of the information that we have. So I'm gonna label this angle A, B, and C, and the opposite side is gonna get just a lowercase of that letter. Okay, so here we go. So the law of sines essentially says, well, I'm gonna make this into two 90-degree angles, two right triangles, right? And in order to find a side if I don't know it, or in order to get an angle if I don't know it, what I would do is I would do the sine of angle A equals, I'm going to call this whatever I want. I'm going to call it X. If you look in the book, the online textbook uses H, but I'm going to use X. So if I do the sine of A, that's the opposite side over the hypotenuse. So that's going to be X over C. And then if I do the same thing with this angle over here, if I did the sine of C, that's going to equal the opposite side, which is X, over its hypotenuse, which is A. So if I tried to figure something out, if I had some pieces but I didn't have everything, let's say I didn't have X, right? I had everything else, but I don't know X. I'm going to solve for X. So what I'm going to do to solve for X on this one is I'm going to multiply by C. So I have C sine of A equals X. And on this one, I'm going to multiply by A. So I'm going to have A sine of C equals X. Well, notice that both of these equal X. So since both of these equal X, they equal each other, which means C sine of A equals A sine of C. Which means if I divided this by A, divide both sides by A, I would have C sine of A over A equals sine of C. And then I'm going to divide this by C, gives me sine of A over A equals sine of C over C. So we're going to have just a rule that actually says this. It says the sine of an angle over its opposite side, over its, I don't really know. Yeah, it's opposite side. The sine of A over A is equal to the sine of another angle over its opposite side. So it's a little bit weird because we're not dealing with right triangles when we're doing this. And this rule makes it very simple for us to find the pieces that we don't have. So let's say that I have a triangle that looks like this. It tells me that this angle right here is 36 degrees. I should use pi, but because I accidentally used 36 degrees, I'm just going to continue with that. It tells me this side is 12, this side is 9, and this side is 14. Okay, it gives me all that information. And it wants me to find these other two angles. So I'm going to call this angle A, and I'm going to call this angle B. All right? So the sine of 36 over its opposite side, which is 12, equals the sine of B over its opposite side, which is 9. And it also equals the sine of A over its opposite side, which is 14. Okay, but I'm going to treat this as two separate problems. I'm going to do this one first, and then I'm going to do this one. All right? So I'm going to do the sine of 36 over 12 equals the sine of b over 9. And I need to do this in my calculator. Now these are going to give us decimals. And I don't have a calculator, of course. So I'm going to be rounding on these. So since I'm going to be rounding, I'm going to round to 3 decimal places. I'm going to round to 4 decimal places. So I'm just going to go the sine of 36 divided by 12. So I get approximately 0.0489, so 490, because it's 898. So it's going to round up to 8490 equals the sine of b over 9. So I'm going to multiply by 9 times 9. So 0.4408 is approximately the sine of b. And then I would do the inverse sine. So I'm going to get b is approximately, inverse sine is on here as well, on the under trig. Inverse sine of answer gives me approximately 26.1574 degrees. Okay, so that was B. I'm gonna do the same thing to find A. So I'm gonna go through that same process. Sine of 36 divided by 12, I already know equals this. So I don't have to resolve that. So I have 0.0490 is approximately the sine of A over 14. So I'm going to multiply that by 14. 0.0490 times 14. 0.686 is approximately the sine. It only gave me 3, so I can't go any further. And then I'm going to do the inverse sine. And it's going to tell me that A equals 43.3143 degrees. So now I found all of my degrees. And that's all that I'm really doing on here. Okay? So, yeah, that's all that we really need to do. So now when I'm looking at this, I'm noticing that the example I used doesn't add up to 180 degrees, so I'm noticing that my sides were not good sides for a triangle. So unfortunately, Lothamer did a bad job, and I apologize for that. The reason is that 36 should have been the smallest angle, and it wasn't across from the smallest side. So that's my bad. I apologize. I'll try to make sure that on the one where I do all the examples, I don't make more mistakes like that. So that's the idea behind the law of sines. I gave you the law of sines and I showed you one example of how to use it. Now I'm going to do a bunch of examples for you on the other video, and I'm going to put your video problems.